Okay, we're going to cover 2.3 polynomial equations today. If you understood 2.2b, the factor theorem, then really this lesson is not that difficult, but because all we're doing now is we're solving polynomial equations. And if we can factor polynomial equations, then we can easily solve them, because remember, solving means find the zeros. And if you have something in factored form, it's super easy to find the zeros, right? All right, so let's discuss here. It says, by the end of today's lesson, you'll be able to understand the connection between the roots of a polynomial equation and the x-intercepts of the graph of its corresponding polynomial function, and you'll be able to solve polynomial equations. And in grade 10 and grade 11, maybe we don't make the best connection between roots and x-intercepts. We kind of say that they're all synonymous, so the roots and the x-intercepts and the zeros are kind of all synonymous terms. But in grade 12, they kind of make you understand it a little more deeply. And really when we talk about roots, we're talking about the equation. So if we're talking about roots, we're looking at an equation and we're looking at the zeros. And if we're talking about x-intercepts, we're really specifically referring to where the graph crosses the x-axis. So that's what this first one means. The real roots of a polynomial equation correspond to the x-intercepts of the graph of the polynomial function. The x-intercepts of the graph of a polynomial function correspond to the real roots of the related polynomial equation. That's just the same thing said backwards. If a polynomial equation is factorable, the roots are determined by factoring the polynomial, setting its factors equal to 0, and solving each factor. And if the polynomial equation is not factorable, you can use technology to find the roots. You can also sometimes use things like the quadratic formula. So just because something is not factorable does not mean you cannot find the roots necessarily. All right, so let's look at some examples. It says solve the following by factoring, so it's actually telling you how. So that's a big clue here. So let's look at the first one. If we look, we want to make sure that one side is equal to 0, of course. And so we look at the left-hand side here and we see there's a common factor. So we're going to pull out that common factor of x. We're left with x squared minus x minus 6 equals 0. And technically, that's in factored form. But the question is it in fully factored form? Can we factor what's left inside the brackets? And the answer, of course, is yes. We go back to our methods that we have for quadratic equations, and we know that we can just use max here, so we can find two numbers that multiply to -6 and add to the coefficient -1. And so those two numbers are -3 and +2. So I have fully factored this. Now, to find the roots, though, we say that x equals 0. We say that x equals 3 when we take the opposite sign, of course, and x equals -2. Easy peasy. All right, this second example, I'm going to factor this, but of course I don't see a common factor here. This is 4 terms. I'm thinking I might be able to group it. I'm always going to try to group it before I revert to the factor theorem to factor. So let's go ahead and try. 2x cubed minus x squared. So I'm going to put the brackets around the first two terms. I got a minus here, so I know that the next two terms inside the brackets, I'm going to have to change the sign of. So I changed the positive to a negative. All right, now I'm going to factor what's inside, find the common factor. I can see that x squared is common, so I'm going to pull that out. I'm left with 2x minus 1. And over here, 9 is common, so I'm going to pull out that 9. And I'm left with 2x minus 1 equals 0. I'm going to put it all together now, and I say x squared minus 9 times 2x minus 1 equals 0. I should have had this over. Sorry about that. And it's not fully factored. This is a difference of squares, so I know that I factor x minus 3. I take the square root of each and one of each sign. There we go. 2x minus 1 equals 0. So when I find the zeros, because now it's fully factored, I'm just taking the opposite sign in each of these cases here. But in this case, I don't just take the opposite sign of this number because I have a 2 here. So a little trickier, but not difficult at all. If you need to go to a margin or something to figure it out, you can just take the whole factor, set it equal to 0, and rearrange to solve for x. And in this case, x is a half. Really, it just represents x is the 0 is the value for x that makes this whole bracket equal to 0. So I put in a half here. 2 times a half is 1. 1 minus 1 is 0. All right, there we go. Okay, so example 2 specifically tells us to solve using the factor theorem, so I'm not going to bother trying to group it. It's not going to work. So this is where we have to use our, in this case, our rational zero theorem, because we've got a 2 here and we've got a 3 here. So our A is going to be a factor of 2, so that's going to be plus or minus 1 and plus or minus 2. Our B is a factor of the constant term here, 3, so plus or minus 1 and plus or minus 3. And we know then that our P of B over A, so B over A, is going to be consisting of the fractions formed with these numbers. So B over A would be 1 over 1, positive or negative. B over A is also 1 over 2. And then it's also 3 over 1 and 3 over 2. And as I said in class, what we're going to try is the whole numbers first. So plus or minus 1. I mean, if you want to, you can rewrite these numbers so that B over A is going to equal plus or minus 1, plus or minus a half, plus or minus 3, and plus or minus 3 halves. I do want you to show me that you have found all of the factors, the leading coefficient and the factors of the constant term, the A and the B. And I do want you to show me all the possibilities for my B over A. So now we're going to pick one. Well, remember what I told you. For 1, you would just look here, 2 minus 5 minus 4 plus 3. So I can quickly do that, scan it with my eyes, and see that it's not going to work. And so maybe the minus 1 will work. So let's try P of negative 1. So that's going to be 2 times negative 1 cubed minus 5 times negative 1 squared minus 4 times negative 1 plus 3 equals 0, which is equal to negative 2 minus 5 plus 4 plus 3. Oh, bingo! That equals 0. So I know, because my remainder is 0, I have a factor in x plus 1. Remember, we take the opposite sign of this number for our factor. So x plus 1 is a factor. That's nice. So now I can go ahead and do either long division or synthetic division, whichever you prefer. And yesterday I did some synthetic division, so maybe today I'll do long division. So we've got x plus 1, and we're going to divide by 2x cubed minus 5x squared minus 4x plus 3. All right, here we go. I wish I had more room. Let me just extend that. All right, so 2x squared times 2x times x is 2x cubed, and then times that is plus 2x. That's a square in there. Subtract, and I get minus 5 minus 2 is minus 7x squared. Bring down the minus 4x. So now I've got minus 7x will give me minus 7x squared here when I multiply this one by this one. Minus 7x times positive 1 is minus 7x. And again, I subtract. This is 0. This is 3x. Bringing down the 3. So I know that if I multiply this by positive 3 here, 3 times x is 3x. 3 times 1 is 3. So I have no remainder, which is supposed to be the case because we decided that x plus 1 was a factor, so the remainder should be 0. So far, what do I have? I'm going to call the polynomial always p, unless it tells me otherwise, and I should go back and look, but it just gave me the expression, I believe. Let me just go back up and look. Yeah, it gave me an equation, but I'm calling it p of x. So far, what I know is that 0, I don't even have to call it p of x, I can call it just 0 equals x plus 1 because we're solving for this, times 2x squared minus 7x plus 3. Okay, is this fully factored? I think not. So I am going to try and factor this. And again, I'm not going to tell you how to factor this. You're going to use whatever method you like. So let me just try the man method here, and in case you forget, I'll just walk you through it. Two numbers that multiply to 3 times 2, which is 6, and add to minus 7. So those are minus 6 and minus 1. I make my little temporary factors with x minus 6 and x minus 1. I bring down the coefficient 2. I reduce my fractions, so this is x minus 3. If my fraction is reduced and I still have a denominator, I bring that denominator in front of the x. So this is 2x minus 1 factored. So now I'm going to just put that back in. Of course, this is the margin here. I don't need to see this work. This is just you figuring this out. So this is x minus 3 times 2x minus 1. All right, I'm in a position now because I've got linear factors here, degree 1 factors. I can't factor it anymore. So I know that x is equal to negative 1, x equals 3, and x equals 1/2 are my roots. And I'm okay with you just leaving it like this as long as you're showing me that this is equal to 0. This is an important piece here, okay, that you're showing that you've actually set it equal to 0 so that you know. Oh, sorry. Let my husband grab that. Okay, so set this equal to 0 and then just show that you've calculated the zeros, or the roots, really. Okay, I'm going to pause the video for a second. Okay, I'm back and I'm looking over my note here, and I don't know why I wrote equals 0. I was probably looking at the function. So we definitely don't put two equal signs on one line. And so really what we're doing here is we're just taking the function, the polynomial function, seeing if it's equal to 0, and that's the factor. So we didn't have to write the whole equation out. Definitely don't want to put two sets of zeros on one line. All right, so let's go to our next example. All right, we have a polynomial function here that is also, we're going to have to use that rational zero theorem again because we have a coefficient. We also have, of course, something that's not in standard form. So we want to make sure we move the minus 18 over and that we have 0 on one side. So our a is 5. So we're going to find all the factors of 5, which of course is plus or minus 1 plus or minus 5. And our constant term is going to be plus or minus 1 plus or minus 2 plus or minus 3. This is going to be ugly. plus or minus 6, plus or minus 9, and finally plus or minus 18. So there's a lot of possibilities here. We're going to have all of these, of course, because one of our A's is 1. But we're also going to have, so I can write those out. And then we also have plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, plus or minus, what am I at? 6/5, plus or minus 9/5. At least I didn't have to reduce fractions, and plus or minus 18/5. Okay. Well, we're going to pick one of our whole numbers to try. So we're going to try with, we can call it b over a equal to, let's see, if we look at our coefficients, 5 minus 8 is minus 3, and minus 3 plus 18 is not going to give, this isn't going to give me 0. So I'm not going to even bother with 1. I'm going to try b over a equals -1. So p of -1 is equal to 5 times -1 cubed minus 8 times -1 squared minus 27 times -1 plus 18. And let's just check to see if that equals 0. So that's -5. That's -8. That's positive 20. There's nowhere near. I'm just going to say p of -1 for the interest of time is not equal to 0. All right, that's all I really care about, right? So now we're going to go and try another number. So let me just look at my function. If I put a positive number in there, that means I'm going to get a negative here and a negative here, which is not going, sorry, I missed that. Positive number here, that's going to give me a positive. All right, so I still think I need to try p of 2. So if I put in p of 2, this is an arduous process sometimes. And when I look at that, this is positive 40. This is negative 32 minus 54 plus, I should probably have a calculator here. So 40 minus 32 is 12. And then, 40 minus 32 is 8. That's not going to work. Okay. So again, p of 2 is not equal to 0. So now I'm going to try, see if that was negative, if that was positive, 72. Okay, so that p of -2 might work. So I'm going to go 5 times -2 cubed minus 8 times -2 squared minus 27 times -2. I keep doing this. Plus 18. All right. So this is going to be negative 40. This is going to be negative 32. This is going to be positive 54 and positive 18, and I think that adds up. This is 72. This is minus 72. So this does equal 0. So p of -2 does not does equal 0 in this case. So now we know that, you can just say so, x plus 2, take the opposite sign, is a factor. All right, so at least a factor. All right, I'm going to do synthetic division because I don't have a lot of room here. So I'm going to take my 2 and my coefficients, and that's going to be 5, -8, -27, and 18. Bring down the 5, kickstart. That's minus 18, minus 36. That's 9. 9 times 2 is 18. All right. So, what do we got going on here? Do I have any room back up here? Let me just double check. Okay, I got loads of room. So I'm just going to go all the way up here. Keep going. All right, so I've got remainder 0 here. So this is my constant x and x squared term. So far, what do I have? I've got that 0 equals x plus 2 times 5x squared, and now I forget, oops, 5x squared minus 18x plus 9. Okay, so on a piece of scrap paper now, I got to try and factor this. So I'll just do it below here and then erase it. So I'm going, two numbers that multiply to 45 and add to negative 18. 15 and 3, so negative 15 and negative 3. So I've got that my temporary factors are x minus 15 and x minus 3. I bring down my 5. I reduce my fraction, so I've got x minus 3 and 5x minus 3. Okay, I'm just going to erase that. Oh, x minus 3 times 5x minus 3. Okay, go back to my color. Okay, so this is going to be 0 equals x plus 2 times x minus 3 times 5x minus 3. And now I easily can find my zeros. And remember this one, if you can't figure it out, you can set it equal to 0 and isolate x, and this would be x equals 3 bits. Okay, so you can see that this is just more of the same, right, from what you did yesterday, but now we're just finding the zeros. Okay, last one. Sorry that this is taking so long. The volume V in cubic centimeters of a block of wood that a sculptor uses to carve a wolf can be modeled by this volume equation, where x represents the thickness of the block in centimeters. It's saying what maximum thickness of wolf can be carved from a block of wood with a volume of 1,332 centimeters cubed. Well, that's going to be my volume. So I'm going to substitute in 1,332 into my volume formula. I am going to, of course, rearrange. And I think I'm going to need a calculator on this one, so I'm just going to quickly find one here. All right. So, 3 might be, let's see, does 3 go into all of these terms? Yes, it does. So I could factor out the 3 just to work with smaller numbers. So this would be 3x cubed plus x squared minus 40x minus 444. Okay, I can divide now by 3 to literally get rid of it on both sides, because if I divide, of course, 0 by 3, I am still at 0. So I'm just going to leave this as 3x cubed plus x squared minus 40x minus 444. Okay, so I'm going to try grouping this, but I can tell you right now it's not going to be pretty, so I'm not going to be able to group it. But I did have a glance at least to check to see if that might be possible. But as you can see here, if I factored out just the common factor of x squared, I'd be left with 3x minus 1, and there's no way this is bigger than this, so it's not going to be able to group. I am going to have to try to find a factor of 444 and 3. So it is impossible to list all the factors. I'm going to tell you right now, for these word problems, you're going to just list the first 3 positive and negative factors, okay? And then it's going to, I promise, be one of those. Or on a test, if I can't make a problem that has one of the factors as 1, 2, or 3, or one of the first 3, then I will tell you to limit your factors to certain numbers, okay? Because the point is not for you to be here all day trying to figure out what the factors are. So b is equal to, and we'll just list a few. We know that this is an even number, so 2 works, and 3 does not go into that. I'll just double check that, but oh yeah, it does. So 3 is a factor as well, and 4 obviously is a factor. But I'm hoping the answer is amongst these. We'll see. Okay, 4 is a factor, and was 9 a factor? Divided by 6 is also a factor. I'm having a deja vu from last year. I'm thinking 6 might be the answer here, but we'll think about that in a second. Okay, etc. So, and then our A is the factors of 3, which of course are plus or minus 1 and plus or minus 3. So our B over A is 1 over 1, 1 over 3, and again I will limit that to the first 3. So 1 over 1, 1 over 3, 2 over 1, 2 over 3, and we could keep going forever here, and then plus or minus 3. Try the whole number, the first 3 whole numbers that you get first. But I'm just going to take a pause here, and I'm actually going to check 6 because I have a feeling that the answer was 6. So let's just, I'm just going to, on the side here, try that, okay? Well, what the heck, I'll just do it down here. So try P of actually positive 6. And I'll tell you why positive 6 is going to possibly be the answer. I know that if I put a positive number in here, that my factor is going to be like x minus 6, right? The opposite sign of this. And then when I take the 0 of that, I'm going to get a positive number. And remember what x represented. X was the thickness of the block. So we aren't likely to get a negative answer here, although some of the factors might be negative. We know that one of them has to be positive. One of the zeros has to be positive. So that's why I would be inclined to use the positive value here. I'm just going to write that a little better. And then we'll see where we go from here. Okay, so P of 6 is going to be, and we're using this equation here because we've simplified it, 3 times 6 cubed plus 6 squared minus 40 times 6 minus 444. Alrighty. What do we got here? 6 cubed is 216 times 3 is 648. So P of 6, 648 plus 36 minus, I can't even read my own writing, that's a 6, 240 minus 444. So 648 plus 36 minus 240 minus 444 is indeed equal to 0. So my memory's not too bad from last year, but that doesn't help you because I'm going back here and I'm thinking you would have had to go through at least all the positive numbers, 1, 2, 3, 4, up until 6. So you would have had to go through quite a number of iterations of this without really knowing which one was going to work. Now we'll see when we get our final answer whether that was the only possible answer, but I do believe it is. So again, I promise you that on a test, it will be the first 3 whole numbers, or if it is only rational numbers, I will give you some sort of clue about that, okay? Because there's no way that I want you to spend your whole test just testing numbers. All right. So we know right now that x minus 6 is a factor. I'm going to use synthetic division then to determine the other factors. What are my coefficients? 3, 1, minus 40, and minus 444. Notice I'm using, not my original, but because I decided to divide by 3 at this stage right here, I just took this thing, I divided by 3 on both sides, and I made it a simpler function. That's what I'm going to go back now and divide into. And so I know that, let me just see here. I'm going to say this is 3 minus 18. This is 19. 19 times 6, 114. 19 times, so that's negative 114. And we subtract 40, 74. And this is negative, hopefully, 74 times 6 is 400. Yeah, negative 444. Okay. I did this. I got a remainder of 0. That's supposed to be an R. And I know that so far then, so x minus 6 times 3x squared plus 19x plus 74, hopefully I've got all the right signs there, is going to equal 0. And I know that this, I have to figure out whether or not this is factorable or not. This is kind of ugly. It's got some big numbers, and I do not feel like figuring out two numbers that multiply to 74 times 3 and add to 19. So what I'm going to do right now is I'm going to use my discriminant, b squared minus 4ac. You recall that from last year, right? And grade 10. If you have b squared minus 4ac, I'll just review it with you, greater than 0, it means there are 2 roots. It doesn't mean it's factorable, but there are 2 roots, which means I would have to use the quadratic formula to find those 2 roots if it were not factorable. If b squared minus 4ac is equal to 0, I know there's 1 root, and again, might be factorable, or it might not be a very nice root at all. So in which case we might still have to use the quadratic formula, or we know that b squared minus 4ac could be less than 0, in which case there are no roots. And what I'm hoping for is that it tells me there are no roots here when I plug in b squared minus 4ac. So from here, I'm going to say a is equal to 3, b is equal to 19, and c is equal to 74. And when I do b squared minus 4ac, I get 19 squared. So I could write b squared minus 4ac is equal to 19 squared minus 4 times a, which is 3, and c, which is 74. All right. So 19 squared, I should know it because, you know, that's my job, but 19 times 19 is 361 minus 4 times 3 times 74, which is 888. Oh, look at that. I get 361 minus 888 is minus 527. So b squared minus 4ac is less than 0, so no real roots. And we don't care about imaginary roots at this stage because we are talking about the thickness of a piece of wood. That's what x is, right, in this word problem. So we don't care if we get imaginary roots. We don't want them. We're working in the real world here with a piece of wood. So x equals 6. And we can conclude then, you have to show me this work. You have to show me that you've gone through this process and you've determined there are no real roots. You cannot just ignore this. You have to either factor it, or you have to use the quadratic equation to find some more roots, or you have to tell me there are no roots. Or if there was another way of doing this somehow, you have to just justify why there are no roots here. Okay, so I need to see this work on a test. So it's a word problem. Therefore, the maximum thickness of wood is 6, and I don't remember the units, but I'm going to go with centimeters. Okay, that's your lesson. Sorry it took so long.